All right, so yesterday we talked about the parent functions. So today we're going to talk about characteristics. So the basic sine and cosine curve, okay? I've given you the graph of a full, like if you put it into the calculator, what you would see on the calculator, okay? Now, the darker portions of the graph represent one period of the function. It's also called one cycle of the curve. It basically is talking about that you're going to see one wave, one full wave in one period. Okay. Now, the other thing you have to remember is that when you're in your graphing calculator and you're dealing with these things, one of the common mistakes my students make is they're in degree mode and not radian mode. If you tried to plug in y equals sine x into a graphing calculator and it's in degree mode, it's going to give you a straight line because the x-axis is going to be in degrees, and from 0 to 10 degrees, there's no change in the sine or cosine function. So it's going to look weird, so be careful. So sine and cosine differ, but not by much. If you notice, they have the exact same range. Both sine and cosine are between -1 and 1. One full period for both sine and cosine is from 0 to 2 pi. They differ that where sine begins and ends on the x-axis like this, cosine begins and ends for one cycle at its maximum. Okay? So they are a little bit different. So sine is symmetric with respect to the origin, where cosine is symmetric with the y-axis. We learned terms for that at the beginning of the year when we talked about odd and even functions. Even functions are symmetrical reflecting over the y-axis. So cosine is an even function, where odd functions are symmetrical around the origin. So if you rotated sine, if you rotated this curve, it would give you this piece over here. Okay, it has rotational symmetry. Okay, those are the easy parts. Now, there are 5 key points in one period of each graph. Those are our intercepts, our maximums, and minimums. Okay, in the sine function, we have 3 intercepts at 0, pi, and 2 pi, and we have 1 maximum and 1 minimum point. Okay? Those are the 5 key points of the sine wave. Cosine, on the other hand, has 2 intercepts, this minimum, and these 2 maximum points. Okay? Those are relative maximums, not absolute maximums. So they both have 5 key points. The difference is that sine has 3 intercepts and a maximum minimum, where cosine has 2 intercepts and then 3 relative maximum minimum points. Okay? All right. So pretty easy stuff so far. So now let's start talking about amplitude, and then tomorrow we'll talk about period. Okay? All of the rules that we learned for reflecting, stretching, compressing, and shifting are all still true for sine and cosine curves. Okay? All those transformations we learned at the very beginning of the year when we talked about A, B, H, and K and what they do and how they affect the graph, nothing has changed. Okay? Nothing. So we're going to talk about amplitude. Amplitude is the vertical stretch or compression, and it affects the range. Okay? So basically, when you hear amplitude, we're talking about the A transformation. So right here, the amplitude, this little A in front of the sine or cosine, which is outside the parentheses and it's our multiplication, that is our amplitude. That is our vertical stretch or compression. If A is 1, there's no vertical stretch or compression. If A is 2, it's been vertically stretched. If A is, say, 1/2, it's been vertically compressed. Okay, so nothing's changed. The difference is that it has more of an effect on the graph than it did on our other functions. Okay, and specifically, the amplitude represents half the distance between our maximum and our minimum values on the function, and is given by the amplitude is the absolute value of A. Because now we're talking about distance. So if there's a -4 in front of the sine, the amplitude is just 4, not -4. The negative represents a reflection. The 4 is our amplitude. When you're looking at a graph, the amplitude is the distance from the maximum to the minimum point divided in half. Okay, and this will make more sense when we look at it as a graph. Okay, so you can think of a vertical center as a horizontal line that cuts the graph in half. Okay, or we call it our center line. That vertical center is always at y equals maximum minus the amplitude. So if you start at the function's maximum point, go to the center of our wave, that will be our center line, okay, or what we call our vertical center. Okay, so let's practice this a little bit. Okay, so on this graph, we're going to graph all 3 of these. We're going to graph y equals sine x, y equals 3 sine x, and of course we always graph the parent function. Okay, so here we go. I'm going to draw the scale. Okay, so I'm going to say this x, this is 0. Okay, this here, this is pi over 2. This is pi. This is 3 pi over 2. And this is 2 pi. Okay, so that's how I'm going to label my x-axis. My y-axis, I'm going to say this is 1, this is 2, and of course we're going to need 3. Okay, so then this is here -1, and this is -2. Okay, so we're going to start by drawing our parent function. Our parent function of sine is something that you're going to have to get used to drawing pretty quickly. Okay, so sine starts at the coordinate 0, 0. So 0, 0. Then it has pi over 2, 1, pi 0, 3 pi over 2, -1, and 2 pi 0. Those are our 5 key points. The zeros, the maximums, and the minimums. Okay? And then here is our sine wave. Okay? And you should be able to eventually draw the parent function that quickly. All right, so I'm going to use blue to draw this one. So this one I'm going to do in blue, the 1/2 sine x. So basically what this is telling me is that I'm going to have the sine wave, but the amplitude is now 1/2. The amplitude in my original one, I'll draw it in black, y equals sine x, there's that 1 out in front. So the original amplitude is 1. That's why the distance from here to our maximum is 1. Okay? Now my new function, 1/2 sine x, is telling me my new amplitude is 1/2. And remember, it works like our vertical stretch or compression. So if you think about it, it multiplies my y values by 1/2. So my original y value was 1. My new y value is 1/2. Here my y value is 0, so it's still 0. So my zeros don't move because 0 times anything is 0, but my maximum and minimums are cut in half. So sine 1/2 sine looks like this. I still have that wave curve to it, but now vertically it's been compressed by 1/2. Okay? Now the next one I'm going to do in red. So again, same idea. Y equals 3 sine x is been vertically stretched by 3, which means my amplitude is now 3. So my maximums and minimums are 3 away from my vertical center. So my vertical center is still right here, right? And again, if you think about it, I multiply 3 times 0, it's going to be 0. So my zeros don't change, but my new amplitude is 3. So the distance my maximum is 3 away. So it's going to be up here. And this one's going to be 3 away. It's going to be down here. So it's going to look something like this. It's going to go up to the maximum, come back down, and it's going to look like this. Notice that my x's didn't change, just like before. Since it's a transformation of y's, it's a vertical stretch or compression. But in this case, what it's done is it's increased this distance right here to 3. And this distance right here is also 3. And going back to this equation here, if your amplitude is your max minus your minimum divided by 2, my maximum's at 3 minus my minimum at negative 3. 3 minus negative 3, that's 3 plus 3 is 6. 6 over 2 is 3. So you can see how that equation will work. Okay? So we're going to practice a little bit. So I've given you some graphs here, and I want you to find the amplitude and our center line. Okay? So our first one, let's look at it. Our maximum point's here. So here's our maximum at 4. Our minimum point is right here at negative 4. Okay? So what is my amplitude? My amplitude is 4. Where is my function centered at? 0. Because the center of it is halfway in between. So this line right here, this is my center line. It's centered here. This distance here is 4, and this distance here is 4. Okay? If a trig function hasn't been shifted up or down, the center is at 0. All right. So let's look at the next one. Okay? Here's my maximum. It's at 5. Here's my minimum. It's at negative 1. Okay? So this total distance here is 6. Right? So which means my amplitude is 3. Now to find the center line, you can either count 3 away from the 5. So 1, 2, 3. This should be where my center line is. And same thing here. 1, 2, 3. Should be right in the middle of my maximum and my minimum. So my center line is at 2. And you probably could have figured out it was at 2 just by looking at it. Like it's basically we're saying, where is the middle? Okay, really easy stuff. Not too difficult. All right, let's look at the next one. So here's our maximum right here at 0. Here's our minimum right here at negative 2. Our total distance is 2, which means my amplitude is 1. And my center is at negative 1, right here. And the last one is easy because this is our maximum here at negative 1. Our minimum here is at negative 5. So this distance right here, the total distance is 4, which means my amplitude is 2. Which means my center line has to be at negative 3. Negative 3. Right in the middle. And that's our amplitude. So the hardest part about this is just knowing how to calculate your amplitude and your center line. Basically division addition. That's it.